Hello and welcome to another Chapter 8 practice problem. This problem is similar to question 15 in Chapter 8, finding the confidence interval for means with t-scores. The problem that we are going to be working with today is a sample of 85 weekly reports showed a sample mean of 19.6 customer contacts per week with a sample standard deviation of 5.6. The question is going to ask us to find the confidence interval for 90 and 95% confidence for the population mean of the number of weekly customer contacts for the sales personnel. Before we go further, we should discuss how to find a t-score. Using our proofs, we cannot prove normal distribution, so we need to use a t-score. Finding the t-score of alpha divided by 2 is similar to finding the z-score of alpha divided by 2. We need to take 1 minus our confidence coefficient, and that will give us our alpha. Then we divide that number by 2, which gives us our area in the upper tail for our t-distribution. For example, for our 90% confidence, we take 1 minus 0.9, which gives us 0.1 as our alpha. We then divide that number by 2 and get 0.05, which is our area in the upper tail for our t-distribution. And finding our degrees of freedom here in this column, we take our sample size, in this case 85, and subtract 1, which gives us a degrees of freedom of 84. So we find 84, follow it over to 0.05, which gives us a t-score of 1.663. Now, following that same train of thought for our 95% confidence, we do the same thing and would take 1 minus 0.95, which gives us a alpha of 0.05. We divide that number by 2, which gives us 0.025. Once again, our degrees of freedom are 84. We follow it over to 0.025, and that gives us a t-score of 1.989. So part A is going to ask us to find the 90% confidence interval for our data. I have the formula that we're going to be using up here in the corner. It'll be there on the next slide too in case you need to refer to it. The formula that we're going to be using is x bar plus or minus the t-score of alpha divided by 2 times s, which is our sample standard deviation, divided by the square root of little n, which is our sample size, times the finite correction factor if it's appropriate for the situation, which is the square root of capital N, our population size, minus little n, our sample size, divided by our population size minus 1. We are not allowed to use the finite correction factor in this calculation because we are not given the population that our sample size is taken from. So with our terms defined here at the bottom, we have x bar equal to 19.6, s, our sample standard deviation, equal to 5.6. We have little n, our sample size, as 85, and our t-score of alpha divided by 2, which we found to be 1.663. So plugging them into our formula, or at least the part that we can use, we have 19.6 plus or minus 1.663 times 5.6 divided by the square root of 85, which gives us 19.6 plus or minus 1.01, which gives us a 90% confidence interval of 18.59, which is less than or equal to mu, which is less than or equal to 20.61. Part B of the question is going to ask us to find the 95% confidence interval for our data. I still have the formula that we're going to be using up here in the corner in case you need to refer to it. And as I mentioned back in part A, we are not allowed to use the finite correction factor because we are not given the population that our sample is taken from. So, just like in part A, with our terms defined here, x bar equal to 19.6, s equal to 5.6, n equal to 85, and the t-score of alpha divided by 2 that we found for 95% confidence is 1.989. So plugging them into our formula, we have 19.6 plus or minus 1.989 times 5.6 divided by the square root of 85, which gives us 19.6 plus and minus 1.21, which gives us a confidence interval for 95% confidence equal to 18.39, which is less than or equal to mu, which is less than or equal to 20.81. Something to note that I wanted to point out was if you notice that our confidence interval for 90% confidence was 18.59, which is less than or equal to mu, which is less than or equal to 20.61, while our confidence interval for 95% is 18.39, which is less than or equal to mu, which is less than or equal to 20.81, is that the higher your confidence is, the wider that your interval is going to be, as we can see here, and vice versa. The less confident that you are, or otherwise the lower your confidence is, the smaller your interval is going to be. This stems from the idea that if you are more confident that your sample mean falls between a certain range, the bigger that range is going to be, while similarly, if you are less confident, you can narrow that range a lot. For example, I could be 99% confident that the age of the person recording this video falls between 15 and 45 years old, or I could be 80% confident that the age of the person recording this video is between 15 and 25 years old. The more confident I am, the larger that range is going to be, while the less confident I am, the smaller my range is going to be. And once again, I hope that this video helped you in understanding this concept, and I will see you in the next video.